Welcome back to the channel. Today we're going to be covering Fusion Manufacturing Milling number 3, and we're going to be specifically doing this part right here. The key topics we're going to cover is how to do a pocket, how to do engrave using tracing, and how to do a step down contour like you see here. Stick around, it's going to be interesting. Before we get started with the manufacturing process, we're going to go ahead and cover a few things. First, on the print, which you can get in class, it tells you what the stock size should be, as well as which work holding we're going to use when we get to that step. But before we do that, we have some design changes to make. Mainly, we need to change this information that we're going to engrave. You need to put your name in here and the year you graduated. So if we go to the bottom here and right click and say edit sketch, and then double click on the text and click OK, we have access to the text. So we're going to change the your name part to your name, and I'm going to do my last name. And they're all in caps, so I'm going to do that. And then the year you graduated from high school. Now, I graduated from high school in 1997, so I'm going to go ahead and modify that. You should just have to do the last two numbers. And then hit finish sketch, and then it brings us back to the beginning. Okay, now that we've made that edit, we're going to go ahead and hit save, and we are going to close this. Now we're looking at the print, and right here it tells us both the raw stock and the work holding we're going to use. And for setup number 1, which is what we're working on, we're going to use vise number 1, the mini mill self-centering vise with the talon grips. So we're going to go to our work holding, milling, and then we're going to go ahead and get into our file. And then we are going to right click and say insert into current design that vise number 1. And we're going to click OK, and then we're going to break the link. Now, the stock needs to change the size listed there, and then you need to do a setup, which I'm not going to show you. If you don't know how to do that, you can watch any of my 2 previous videos that are FMM 1.1 or FMM 2.1, which will explain this process to you. Okay, information you do need for the last page of the setup: the program number, the program name, and don't forget you put your last name, and the work offset will be G55 again. So now that we've done that and we set the origin in the middle, we can go ahead and get started on our processes. So a couple of processes I'm not going to show that you need to do is probe the part, face the part, and do an adaptive clear and a finish contour around the outside. Don't forget to push it 20 thousandths below, so when we do the flip to machine off the top half, we get a nice clean edge. Okay, so we've done those things: probe, face, contour the outside edge, finish. Okay, we've done those things: probe, face, adaptive clear, finish contour to size, pushing it 20 thousandths below the bottom of the part. Now we have, if we zoom in here, we need to cut off this top area. So we need to do like a step down adaptive clear and contour. So we're going to go to milling, and we are going to go to a 2D adaptive. And we're still going to use the 3/8 end mill, but we only want to do this one line. And if we click on it, it will do just one line. If we, because there is only one line here. But one thing I want to show you is if it was a chain of lines, we could double click on this and it'll open this up. And you'll notice it'll switch from closed loop to open loop. And this would allow you to select multiple lines in a row and achieve this same thing. So I'm going to go ahead and click OK. And then I'm going to rotate it over here and click on this so it gets the other side as well. And then the other thing we want to do is we want to cut all the way to the bottom. We don't want to leave any material behind. So we're going to go ahead and come over here to stock to leave and put it to 0. And then click OK. And it's going to adaptive clear away that. And then we need to do a finish contour because it leaves a little bit of extra here. So we're going to go back and do a contour. Select only that single line. Make sure the arrow is on the proper side. And then click OK. And you'll see here that we now have our lines. The next new element we're going to cover is called pocketing. So we can do adaptive clear, but there's also a tool called a pocket. So we're going to go ahead and do a pocket, and we are going to switch our tool to a 1/4-inch end mill. So we're going to come down here to the student library and pick tool number 4, the 1/4-inch end mill. and pick brass. By the way, all your other ones need to be in brass as well. And that can be adjusted right here as well. It gives you the option. So you don't need to go in and edit each tool very deeply. You can just switch to brass. We are going to select this edge here, which gives us the entire bottom. And the major difference is how this approaches and the pattern it produces on the floor when it machines it. So this is going to give us a good, clean, uniform pattern. So we don't need to really make any adjustments except for the last one where we're going to turn off stock to leave. And this isn't very deep, so we can do it all in one pass. And then we're going to click OK. Well, I take that back. We're going to switch to ramping helix. That's fine, but we're cutting in brass. It's a soft material. We don't need a 2-degree helix. We're going to go to a 6-degree helix and click OK. And what you'll notice is it spirals in, and then it does this very geometric pattern to get the floor nice and clean, which looks better than adaptive clear, where it just does whatever it wants to get the floor and leaves tool marks very obviously all over the place, where this is going to leave us a nice clean bottom. Now, the next step is we need to drill these holes, and we need to apply a 2D chamfer of 20 thousandths to these, all of these edges. So I'm going to go ahead and do that process. Okay, I went ahead and drilled the holes, as you can see here. That's something you should already know from previous lessons, so I'm not going to show you that. And I've selected these two edges in my 2D chamfer. I can also select these edges, which I want to put a chamfer on as well, and the cutter will accommodate them. But I selected a surface, so I'm going to get rid of this one and pick just the edge. Now, the chamfer will not, cutter can't get all the way to the edge. Fusion knows that, and it will compensate and stop it short of getting all the way around. But the goal is to not have a sharp edge for handling. Our chamfer is 20 thousandths, so we're going to come over here to chamfer width of 20 thousandths. Now, 20 thousandths. Now, the tip offset, the bigger you make the tip offset, the closer the diameter gets, the closer it can chamfer into this corner. So I'm actually going to up this to like 0.1, which when you add these together is almost all the way up the chamfer. And if you click OK, you will notice that the line, it goes way lower, but it gets much further around on this part right here, where if I left the tip offset, it would small, it would have been over here. Now, this isn't perfect because notice the internal chamfer isn't there. The problem is when we set that tip offset, it has to move the cutter over and down so much that it would hit the floor here. So the easy way to fix that is to go into edit, and we're just going to take off that inner ring. So I'm just going to unclick that one, or I'm going to exit that one so it goes away, and then click OK. And then I'm going to do a second 2D chamfer, select here, come over and do our tip offset of 0.02, and now leave it near the bottom of the cutter and click OK, and now it will come in and do that chamfer and not hit the floor, and we get the desired effect. The last new thing we need to cover is how to do engraving. Now, there are two forms of engraving and trace. So engraving is designed for more of a bubble letter, where these are stick lines. So all we want the cutter to do is cut exactly on top of the lines, and that is done through tracing. And we're going to use what's called a diamond drag, which is a pointy cutter with a diamond on the tip of it, and it's actually not going to even rotate. It's just going to scratch lines into the material. And it's spring-loaded, so when we press down, it'll just press in a little bit and scratch the line. So we're going to go ahead and do that using trace. So we're going to click on trace. We're going to come over here into our tool library, and we have a diamond drag as tool number 7. It has 1 RPM because Fusion and Haas doesn't like 0 RPMs. So if we put in 1, it kind of tricks it. It won't actually rotate. And then we just select the writing, and it will find it. We come across here. We don't need to do anything here. What we do need to do is right here where it says axial offset. This is where you give it the depth. And for ours, it doesn't really matter on the depth. We're going to do negative 0.05. It's just going to push it in, and the spring-loaded diamond will just press against the surface enough to scratch in the surface. And then we click OK. Unfortunately, when we simulate it, it shows it much bigger than it'll actually appear. It'll appear a very fine line here. So now that we have it all together, we can do a simulation. So we're going to go ahead and hit simulate. We have green checks for everything, which is a good sign. It took a moment for the computer to process the simulation, so I stopped recording. Now that we have it up, we're going to go ahead and hit play, and we can see it's probing. And then it's going to come face. It's going to do our adaptive clear. I'll zoom out a little bit, adjust the view. And we got those wings cleared off. We did the pocket. We're going to now do the drilling and then the chamfering. And then finally, it's going to do the tracing. And the tracing isn't 100% accurate because it goes far deeper than we actually will in reality, but it gives us an idea of what it will actually accomplish. And if we look, there's no collisions, everything looks good, and we can go ahead and finish the simulation. We're now ready to post-process this. Make sure you select the correct post-processor, which is the next-gen controller, which should automatically come when you use your mini mill, and then hit post, take that file up to the simulators in the front, and let me take a look at it. Now, one more thing, there will not be a video for number 3.2 because it's just the back where you're going to flip it over, probe it, or face it off, probe it, and put it 20 thousandths chamfer, which you should know how to do. It's essentially the same process as FMM 2.2. And then the next process after that is to machine the keychain, which you're doing completely on your own. Thanks for watching. Hope you learned something, and I'll catch you guys in the next one. And I'll catch you guys in the next one.